So here the same model, we can use same data, and our passive loading scheme will remain same. So let's do in the same model, so we can compare both at a time. So from where we can find the DC motor model? From Simscape. Under Simscape you can go to the SimPowersystem. Here in Simscape, SimPowersystem library, and in SimPowersystem library, in the specialized technology, you can find the different component. Here machine, you can find the machine. So under Simscape SimPowersystem library, you can find specialized technology, and here machine. So in machine, just we will first take the DC machine, DC motor. So here is the field winding separate available, armature winding available. So for this we also have the field winding voltage, 300 voltage. 300 volt is the field voltage. And let's first set the parameters of this DC motor. So we can have the different parameters: armature resistance and inductance, then field resistance and inductance, then field armature mutual inductance also is there, then inertia, and then different component of friction. You can also set the preset model. Here already available 5 HP, 10 HP with the different variation rating, 240 volt armature voltage, 300 volt. This is what model we used here. But if we select this model, then we will not able to change the total inertia, where we need to add the inertia of vehicle also considering the cylinder. So what we will do, we will use this preset. We will not use any preset model, and we will input the model parameter preset value of the 5 HP DC motor. So let's add the armature resistance. It is 2.581. This is 0.028. Let me fill it faster. So here I have completed all the datas. Resistance of field winding 281.3 and 3.156. So I have shared already the data sheet where all the parameters including the inertia and viscous friction and column friction and all this data for the particular DC motor models are available. Now this DC motor is shunt DC motor. It can be confirmed by the resistance of the field winding. If resistance of field winding is very low, as like the resistance of armature winding, then it means it is the built for DC series motor. So this cannot be used for the DC series motor. We know the torque of the DC series motor is very high and proportional to I square, generally used in the electric locomotive, but here we are having the model of DC shunt motor, right? So if we are having the data sheet, in the data sheet you can see, consider the field resistance. If it is too high, it is shunt motor only. So this is the DC shunt motor and data are available. So let's use it. First we will use the DC source. DC source is available in the electrical source under the SimPowersystem. So first we will take the DC source. I will rename it to VDC. We require two DC source, one for the field because field voltage is different. I am writing VF. Field voltage is 300, so I will simply make it 300, and I will supply the field voltage to the field winding 300 volt. It will remain fixed, and this voltage is 240 volt initially. Let's check. For the 240 volt, both the models are same. For the 240 volt, when we applied, the speed was 94 or higher. So this is the DC motor. Now the same way we need to use the speed torque characteristic. So here I am using the speed torque characteristic. So torque is input, and here we require the speed in kilometer per hour, and this speed will be radian per second. So we will use from the commonly used block, take the bus selector, so that we can have the different measurement parameter from this motor model. Select it. So speed, current, field current is not required, torque. So 3 parameter I am selecting. Just remove this signal. So first one is speed in radian per second. So this is radian per second, and we want to convert it into kilometer per hour. Here we already converted. So for simplicity, I will drag this 3 block and connect it. Right. So here it is in radian per second. Here it is in kilometer per hour. Right. So without thinking much about conversion, I have used this, and this will be speed in. This is radian per second, and this is connected over here. Right. So let's see, and here we are measuring the speed in kilometer per hour. We can use one scope here. We will simplify it later for better visualization. As of now, one more scope, and we need to add the power GUI block. Search for the power GUI. So you might know the basic things about using discrete and power GUI block. If anyone want to start from the scratch for the power electronics simulation, they can go for the course MatLab for power electronics converters. It may be helpful for the electrical and power engineering or power electronics engineering students. So here are having the two systems. One is simulation model, and here is from the SimPowersystem, Simulink block and SimPower. Both motor model are same. Here also I am applying the 240 volt, so we can compare, and I am running the simulation, so you can see. So it taking more time with compared to previous one. It is 100 second simulation because 100 seconds required. I am stopping it, and let's observe. Here what is happening in our scope, because now we have converted into discrete, so our scope will store the too much data, and we need to remove this limit. You can increase increase this data point set limit, or you can remove this, so that we can have the full data from the starting. See what's happening. This is not changing, and suddenly it is achieving the final speed. Right. So why it's happening? You can see it is rated speed. Finally, suddenly it is achieving the speed. But what's happening here? We forget to input the inertia. So let's input the same inertia, 200 multiply by 0.279 multiply by 0.279. So now it's fine. Now both model are same. So this is the passive loading scheme. We have used the inertia of the vehicle considering the cylinder, and we have used the torque speed characteristic to load the motor with the vehicle model. So let's run it again. So now you can see both the speeds are increasing in km/h. It's almost same rate. So Simulink model and motor model. So let's take the time to complete the simulation of 100 seconds. We need the speed beyond the 94 km/h or up to 97. Let's complete 93. Now it is slowing, so I am stopping the simulation and let's observe the response. Here I have selected the data point, remove the limit, so you can see how response is visible and same. So if we change it, here also voltage 110, here also 110. You can see current is reduced, but with the same input power is also reduced, and that means our vehicle model is supplied with the less motor power. So what is the value of motor power? Maximum speed will be around 54. Let's allow this simulation to complete so we can have idea for the 110 volt. Okay, I am stopping it. So speed is reduced, maximum speed around 56 km/h, and our motor, if we consider the voltage 240 and current 20, it is around 3.7 kilowatt, and now input power is only around 2.2 kilowatt. So 2.2 kilowatt motor if we use, then if we apply the rated voltage, then this much speed can be achieved with the 200 kilowatt 200 kg vehicle model. Now why this is happening? Because this motor is not specially designed for the electrical vehicle or this kind of load. This is the shunt DC motor, that data we have taken, which is used for some other purpose. So now you can understand why we need to select the particular motor. So as we have built the vehicle model for the specific vehicle of Maruti Suzuki Dzire model, the same way when we are having available the data of the electric motor that is used for the electrical vehicle purpose only. So you will find the number of electric motor in the market, and from their data sheet we can build the motor model in this MatLab Simulink as well as with this also, and it will give us idea if we purchase that motor how it will perform with our selected vehicle model, and that can be completed. So here you need to understand this voltage is reduced, that means power is also not 5 HP, voltage is power is reduced from the 3.7 kilowatt to almost 2.2 kilowatt, and this is why, because current is limited. If we exceed the current limit, then the winding may damage. Else if you want to show the higher power rating, then also fine, then you can use the 240 volt, and you can say 240 volt is the voltage and current limit is higher. If current limit is higher, then it may be possible input power is higher, you can show like this, but because we have used the actual motor model, it is better to restrict the data set, limit the current into this. So now to have the better visualization, let me delete all this and we will see. I am just deleting the Simulink model so that we will have only the here is the input dot, here is the response, this is the DC. So now you can realize the model of DC motor. Now those who belong to electrical engineering, they know that here different power electronics converters like DC-DC, 4-quadrant operation of DC motor, and this all converter topology can be easily implemented, and also the current controller and current limiter can also be implemented. If we are using the DC series motor, if we are having data of DC series motor, it will give the higher starting performance. We can also replace this motor by the different other available model available in the Simulink library, like the switch reluctance motor, then induction motor also, and we can also check the performance of the vehicle. So once vehicle model is ready, we can have the two options. If motor model is available and data are available, then we can easily check the performance of the vehicle for that motor, or we can use the different motor model available in the Simulink library. So different specific models are available for each, like the for DC motor different models are available. But if you select this model, we are unable to input this total inertia, right? So it will be taken automatically, so it is not possible. So we should have the data. I am sharing the data of all the DC motor and also trying to collect the data for different other motor model. So we can have the specific model, and we will also see how, if we are having the data sheet available in the available for the particular specific EV motors, then it will be better and we will use it. So hope you got idea and enjoyed this session. Thank you.